Okay, let's graph y equals 4x squared. I do know that it must go through the origin and be kind of skinny or tall because of the factor 4. So I'm thinking it's going to look something like this. But if they want a graph, then they probably want more accurate points. I do know again that it goes through 0, 0, the origin, because it's of the form y equals ax squared. And since a is positive, that's how I know it opens up. So I'm going to put a couple of values in. I know zeros, it's going to go through 0, 0, and plug that in and see what it gives me. So once I have those ordered pairs, it looks like it goes through negative 216. That's going to be way up there. Same thing for this one, positive 216. So let's just take care of negative 1 up 4 and positive 1 up 4, and then I'm going to draw my parabola through that. So notice the symmetry. Remember, the vertex here is, not that they asked for it, but it's good to know the vertex is 0, 0. The axis of symmetry goes right through the x-axis, so the axis is x equals, or right through the y-axis, I'm sorry. X equals 0 is the equation of the vertical line that goes through the vertex. And also pay attention to the symmetry. To the right and to the left of the vertex, the same images happened. 1 to the right and 4 up, 1 to the left and 4 up, or these two ordered pairs are also symmetric, 2 and up 16 or negative 2 and up 16. So if I have an image of an ordered pair on the right side, I can get the corresponding image on the other side as well. So since it said graph, even though I knew what the sketch would look like, I got a couple of actual points to plot. So again, this one has the form y equals ax squared, so I know it's got to go through the origin, 0, 0, and it's got a coefficient of 1/5, so it's not going to be skinny or tall, it's really going to be sort of widened up, and I'm going to make an xy chart and get some more accurate points. So I might want to put some values that are divisible by 5 once I put them in and square it, because I want some accurate points to plot. So I picked 5, I put it in, and I got a 5 for my y value. And since there's symmetry going on about the y-axis, the axis of symmetry, if I put a negative 5, I know without doing the math that I'm going to get the same value of 5. So I know it goes through the origin, 0, 0, and I could do that even with the xy chart. If I go 5 to the right, I'm going 5 up. And then due to symmetry, that same exact image is on the other side as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 up. And then that should be enough for me to draw a parabola. So there's my parabola through those ordered pairs, and it does look sort of wider compared to the x squared graph we looked at. Remember, always choose the vertex and one other ordered pair for the XYZ program for it to draw an accurate parabola. Alright, graph this one, y equals x squared plus 5. I know it has the form x squared plus c, and since this is a positive 5, I'm guessing a sketch would be 1, 2, 3, 4, 5. It opens up and goes through 0, 5, y-intercept of 5. But since it's at graph, I'm going to go make some xy chart and have some more accurate points. Again, if I let x be 0, I already know it's going to go through 0, 5. Maybe I'll put in a 1 and a negative 1 as well. So again, knowing that 1 corresponds to 6, automatically negative 1 will correspond to 6 as well, because it's on the other side of the axis of symmetry. So let's go plot those 0, 5 as I had suspected, because it's a parabola shifted up 5 units. 1 and 6, and then negative 1 and 6. And I'm going to plot some more points just because I want a more accurate graph. I'm going to put a negative 2, and that's going to give me a 9, it looks like. And I know that a positive 2 should also give me a 9, because it's the exact image on the other side of the axis of symmetry, or the line that goes through the vertex. So at negative 2, I'm up at 9, and at positive 2, I'm up at 9 as well. Then I draw my parabola through those 2 points, or through those 5 points. And again, there's my parabola, and we know what the vertex is. The vertex can easily be read at 0, 5, because it was shifted up 5 units. And the axis of symmetry is x equals 0 again, going right through the y-axis. Okay, example 4, graph y equals 121 minus x squared. Again, it looks like it's of the form x squared plus c business, but notice there's a negative in front of the x squared. So I would rather write that as a negative x squared first, and then the positive 121 that's with it. That way I clearly can tell that this is an upside down parabola because it's a negative x squared, and that it was shifted up all the way up to 121. So a quick sketch, if I had to mentally guess what this looks like, I would say, well, it was shifted all the way up to 121. It doesn't open up, but it actually opens down. So this is what the sketch would be in my head. Then I would actually go find ordered pairs to plot on this graph. So let me make an XY chart to get some ordered pairs. If I put 0, I know I'm going to get 121 because that's going to be the y-intercept. Let me put some other values, like maybe we'll put, now notice I put in a 2 and a negative 2, which are to the left and to the right of the vertex, which is 0, 121. So I'm going to get the same outputs for the y values. Be careful when you plug in the negative 2 and the 2 because it goes in place of the x, and the negative outside is just waiting around. So you actually get a negative 4 here and also a negative 4 here because you got to do order of operations. Simplify this first and then drop the negative in front of it. So we're going to go plot those ordered pairs. So I have 0 and 121, let's say somewhere over there, right above 120, and then 2 and 117, so like maybe somewhere here, and then the exact same image on the other side at negative 2. And I'm going to go get some more ordered pairs to get a pretty good idea of how this is going to open. And I think what I'm going to do instead is I'm going to try to get the x-intercepts by letting the y value be 0, because that'll give me a pretty accurate graph. So if I add x squared to both sides, I get x squared equals 121. And notice we can quickly use the square root property and get the two x-intercepts to be 11, 0 and negative 11, 0. Again, I chose to find the x-intercepts because I know it was opening down because of the negative, and eventually it's going to hit through the x-axis, so I might as well find the accurate points to plot. So my ordered pairs, 11 zeros on the right, negative 11 zeros on the left, and then I got 117s way up there, and 121 for my vertex. So I'm going to try to draw the parabola through these. So there's my parabola. And I can clearly see that the vertex is the y-intercept way up there, and it's got a vertex of 0, 121. And the axis of symmetry goes right through it, which is the y-axis, and the equation is x equals 0. For this parabola, they want us to find the intercepts and the vertex, and then sketch the graph. So I know it's one of those shifted ones, and I'm just going to go through and find the intercepts first. So x-intercepts, we're going to make the y 0. Always the y becomes 0 for x-intercepts. And once I do that, notice it's going to be factorable. The GCF is an x, and since it starts with a negative, remember we said we would get in the habit of pulling out a negative if it starts with a negative. So when I do that, I actually have a positive 3x left, and this positive switches into a negative and only a 2 left. Distribute and make sure you get back the original binomial, which we do. So this switched to a positive and this switched to a negative. Now pop out your solutions. Divide by negative 1x is 0. And if this one's equal to 0, it looks like we get x equals 2/3. So our x-intercepts are basically 0, 0 in ordered pair form. Maybe they don't want it in ordered pair form if they just want it separated with commas. 0 and 2/3. But notice that it's 0, 0 as an ordered pair, and 2/3, 0 as an ordered pair as well. For the vertex, remember the formula is x equals negative b over 2a, and in our problem a is negative 3 and b is 2, because b is always with the linear term and a is always with the quadratic term. So negative b says negative 2 over 2 times a is negative 3. That's going to be negative 2 over negative 6, it looks like. Divide top and bottom by a 2, and that's a positive 1 and a positive 3. Now I have to go find the y value by going back into my equation and plugging that in. So it looks like when I plug in a 1/3 into my equation of the parabola and follow order of operations, I end up with a y value of 1/3 as well, so the vertex is 1/3, comma 1/3. So I'll have to approximate it in the graph actually. X coordinate 1/3, y coordinate 1/3. And this is going to be kind of hard to graph because I have 0, 0, and now I have to go to 2/3, which is like 0.67 approximately, and 0, so like right there maybe. They should have given me a bigger, so maybe right there is like 2/3, and then 0.333, 0.333 is the vertex, so approximately we're looking at 0.3, comma 0.3. So 0.3 to the right and 0.3 down, there is the vertex, which is really a bad graph to be looking at. So this is very annoying to graph it here. I brought another graph and jotted down the information. The vertex we found was 1/3, 1/3. The x-intercepts are 0, 0, and 2/3. So I'm just going to go graph it on here, and I'm going to scale it so we can see 1/3 easily. Let's say that's 1, this is -1. And let's say that's 1 and -1 for the y-axis. Let me actually call this up here 2/3, and this -2/3 is the lowest ones. So I'm really going up by 1/3. 1/3, 2/3, 3/3, which is 1. 1/3, 2/3, I'm only going up to 2/3. 1 would be somewhere up here. And remember, this is my parabola. We found the vertex to be 1/3 of the way and 1/3 of the way up. And then the x-intercepts were 0, 0, and 2/3 of the way to the right, and 0. And we know that it opens down because of the negative. So there's our parabola, which kind of looks wide because I've zoomed in so much and my scale is going by 1/3. Over here, if we did it over here, you would see that it would look skinnier, narrower because of the factor 3. Alright, next example. The height of a football t seconds in feet after being kicked from the ground is given by this quadratic equation. Part A says factor the expression for h. So here's my expression. It starts off with a negative. I'm going to pull out the negative, the 16, and they also have a t in common. And when I do that, I'm left with a positive t, switch the sign because you pulled out a negative, minus 80 divided by 16 is 5. So there's the factored expression for h. Part B says find the horizontal intercepts, in other words, kind of like the x-intercepts. So I make my y or my h 0, and then I pop out those two solutions. So there are my two t-intercepts, 0, 0, and 5, 0. I also have to go find the vertex. So I use x equals negative b over 2a, or t in this case. A is negative 16, b is 80. I go plug them in. I find t to be 2.5. Now I go plug it in to find h in this equation. And when I do that with the order of operations, I get 100. So my vertex is, remember, th like xy, t is 2.5 and h or y is 100. I also have to graph this. I do know that the x-intercepts are 0, 0 and 5, 0. And I also know that the vertex is 2.5 and all the way up to 100. And the vertex is always in between the two x-intercepts. And I do know that it opens down because of this negative sign, so I just make my parabola opening down. So there is my very crooked parabola opening down. Part C says, what is the maximum height? Well, we can clearly see the ball went up and came down, and the maximum height is occurring at the vertex, which happens to be 100 feet high. That's the maximum height. When does it reach this height? The question refers to when, which is time, and that would be at 2.5 seconds, basically. 2.5 seconds later after it was thrown, it's going to reach that maximum height of 100 feet. The x-intercepts would imply that the height was 0 to begin with, then it went up, and 5 seconds later it hit the ground again, so the height is back to 0.